Hello and welcome to another video. In this video we're going to be working on minimum number of arrows to burst balloons. And basically here you have a bunch of balloons that can be anywhere on the y-plane, they don't really tell you, but you have x coordinates for them. So the x coordinates are where the balloon starts and where the balloon begins. And you can shoot an arrow on an x coordinate and it will go straight up on the y-plane and hit everything that's on that x coordinate. And you're basically asked to return the minimum number of arrows required to burst every single balloon. So let's take a look at this first example. So here they tell you that you need 2 arrows total. So you can shoot an arrow at 6 that will burst these 2. And then you can shoot an arrow at 11 that will burst these 2. The second example, none of the balloons overlap, so you need 4 arrows. So that's one hint already, seeing like if nothing overlaps, you need 4 arrows. But if something overlaps, you need to determine like how many arrows that saves. And then in the last example, you have 2 arrows, so you can shoot 1 arrow at 2 that will burst these 2, and you can shoot 1 arrow at 4 that will burst these 2. So the basic idea behind this problem is not to figure out like where we shoot the arrows, but how to combine intervals into 1 arrow. And that's what we want to look at. So let's say this is the x-axis, and let's just say we're not going to give out numbers, but we're just going to draw a picture. So if I draw a picture like this represents a balloon that is like, this is the x-coordinates of that balloon. And that's what we're going to do. I could probably actually use these circles. So let's just say we have a balloon like this, and let's try to make it like fit correctly. So let's say we have a balloon like this. And then we have another balloon. Let's say maybe it starts here and ends here. Hopefully you can get that to work. Yeah. Okay. So you know if 2 balloons overlap, then you can just shoot an arrow. There's going to be some place to shoot an arrow in between them, right? But that doesn't necessarily mean like you can just take all the intervals that overlap and combine them. Because like, what if we have a balloon like this? Right? Like here, you can't, like these all overlap and you can combine them. Well, they don't all overlap, but like if you were to take the first 2 and combine them into an interval, then that interval would overlap with the third one. So you can't just like merge intervals and count the number of intervals you have. But basically, for 2 balloons, it's kind of straightforward to figure out how they overlap, right? Like if they overlap, you can just shoot 1 arrow. But the question is, what happens when we add the third one? And so the thing is, for all these intervals, you're always going to be sorting, or almost always, you're always going to be sorting by start index. So your intervals will be like increasing by start index. So it's like this is start, this is the end. And to know if a third interval overlaps with the first 2, it's always going to have a start index like greater than or equal to the start index of the first 2, right? So the third balloon will always start at least like here, let's say, right? It can't start like over here or something if they're increasing order. So to know that it overlaps with the ones we have already, basically all we need to do is store the end index of the one that ends first. So whenever we merge, we're not going to do a complete merge. We're just going to store the end index of the smaller end. So like here, we're going to store this end index over here. And if our balloon, the third balloon we're adding, has an end index, has a start index greater than that, right? Like if it's over here or over here or over here, then it doesn't overlap. And that's kind of the idea. So if this balloon is like this, let's say, then we could be like, okay, well, we stored this index over here, right? And this new balloon does not overlap with that. And then whenever our like balloon we're adding doesn't overlap with all the ones we have currently stored, that we're determining whether we can fire 1 arrow at the whole thing. If this doesn't overlap with all of them, we can just say like, okay, we need 1 arrow for these 2. And then we'll just put in our new interval. So then we'll just put in our new interval wherever that is, and then we'll add more. And so that's kind of the idea. So let's say we have an interval like this. So this will make it a little bit clearer. Let's say we have an interval that goes like this. And then we have another interval that, let's see how I can do this thing. Ugh. Okay, let me just try to copy it maybe. Okay, there we go. Let's make it smaller. So let's say we have another interval that goes like this. Our first interval will end here, and then our second interval will end here. So we're going to store this location here. And our third interval might end even smaller. Like our third interval might look like this, let's say. This should work now, I think. Yeah. So this could be our third one. And then we're going to be storing this location here, right? So we basically just store, whenever we have like an overlap of all of them, we just store the one that ends first. And then whenever we put in a new one, we just check, does that new one overlap with the one that ends first? And if it does, then we're going to update the end index again, and so on. And for and let's say we're trying to put in an interval like this. This will be our next one. So let's say it goes here. Then we could say like, okay, this interval we're trying to put in now doesn't overlap with this end index. So we need one arrow for all of these ones that we have. And then we'll just start with our new interval that ends over here. And we'll basically just keep doing that. And then at the very end, we'll have one more interval that like we're still storing. So whatever our interval is at the end, we'll add one more arrow there. And that's kind of the idea. So to keep track of all intervals that overlap, they have to not just like overlap. They have to all overlap with each other. So like so if we have like A, B, C, A has to overlap with B, B has to overlap with C, and C has to overlap with A. They all have to overlap for this to work. And to do that, you basically just store the smallest end index. And so we can code that. So we are going to have like an end index currently, and then we'll have a result. So we'll have like a result or like arrows or something, make it 0. And then we are going to store the end index of the first point. So we'll just say like, oh, we want to store our points, obviously. It's like almost interval problems. So our end index will be, or end, will be points 0, 1. Then we want to loop through the rest of them. So for I in range of points, or we can enumerate if we want to. Let's just do it this way. For I in range points, and this should be 1, and this should be length points. So basically for our new interval, we're going to check for all the ones we have stored. We don't really care how many, because all we're counting is the number of arrows. So for all the ones that have stored, we're going to have this minimum end, and we're going to check, does this start overlap with that? So if points I 0, which is the start of the current interval, is greater than end, that means they don't overlap. So then we add 1 to our arrows to shoot everything else that was overlapping before, and we're kind of starting like a new arrow. So arrows plus equals 1, and our new end will just be our current point end. So points I 1. Otherwise, if it does overlap, like I said, all we really need to store is the smallest end, because our new point has to overlap with the smallest end. Because it overlaps with the smallest end, it'll overlap with the rest, because that's the smallest one, right? So we can just say this should be end equals, and this should be end equals minimum of end and points I1. And then finally, like I said, we will have like an interval stored that we're currently holding on to at the end. Like let's say this point is an array of length 1. Like we'll have a point here. We'll never go into this loop. Our arrows will be 1. Our arrows will be 0, so we'll always want to increase by 1 at the end. So we can just return arrows plus 1. And yeah, that's kind of the idea. That's how you're checking for like the strong overlap, where like the current interval overlaps with all of the intervals we have, not just like, we don't just combine every 2 we see and keep merging and return how many we have there. Okay. And yeah, as far as the runtime, it's whatever, I guess. Like everyone's runtime is kind of the same, and everyone's code is kind of similar. Like they just sort and then do some kind of while loop, so it's not a big deal. But yeah, you can probably make it like a little bit, like I think there's some solutions where you sort by like end or something instead of by start, but I thought this was like a little bit more intuitive. And then just you realize that you have to just keep track of the smallest endpoint in all of the intervals you currently have. So as always, for most intervals, it's n log n and O1 space. Yeah, I think that's going to be all for this one. This one's definitely a trickier interval problem compared to most. To try to figure out like how do I store all the current points instead of trying to figure out like where I shoot my arrows from. I don't really care where to shoot the arrow from. I just care how many things overlap, and if they overlap, there is a possibility to shoot an arrow somewhere there. So yeah, it's going to be all for this one. If you did like it, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.